and I want to talk about some work I did on integrating Apache Calcite and Clojure. And I wrote a small library called calcite-clj, and it's available on GitHub and on Clojure, so you can include it in your project. The plan for today is to talk a bit about Apache Calcite and Clojure and my motivation for doing this work and how the integration works, and then some future directions, and hopefully have enough time to show some code examples and demos. You guys know about Apache Calcite more than I do, so I'm going to skip fast over this part. Don't know how much you guys know about Clojure. It's a pretty concise function language. It's a Lisp. It's fast to prototype via REPL, and I hope to get to show you this. It has by default immutable persistent data structures, and it's usually low code churn in the ecosystem, so libraries don't change that much because of the immutable data structures. Yeah, so why Calcite plus Clojure? Well, they both start with C and end with A and have the same number of letters. I think they are a good fit together, and I would like to use Calcite from Clojure, which is my current preferred programming language. Long term, I would like to explore if I can expose SQL query language to web developers instead of calling REST APIs and something like that. They could just call direct SQL from the browser, and the engine should take care of security and visibility for data and stuff like that. I think this relates to the GraphQL Calcite project that Gavin worked on. So what calcite-clj offers is a small Clojure library that you can implement in your Clojure projects, and then you can use a Clojure function as a Calcite schema factory. So in essence, you can implement Calcite adapters in Clojure. I didn't go further than this because it's just exploratory work, but works pretty well so far. So how would you use calcite-clj? Just follow a couple of simple steps. You add it to your project. If you use Debian, you have this part. If you use Gradle or other tools, you have other ways of adding the dependency to your project. This is the link to the Clojure, which is a Maven repository where I published the library. You'll need to add that to your project as well. Once you add this library to your project, in the namespace of choice, which is calcite-clj simple here, you define a function that will create the schema. This is my schema here, and it will return an implementation of abstract schema that's imported from Calcite packages. I'm using Proxy Plus. It's another Java library, Clojure library for implementing abstract Java classes in Clojure. Once this is done, you build your model JSON file, and the important bits here are to use the Java class for the integration, which is this one. This is defined in calcite-clj. And also defined an operand that contains the full definition of the namespace and function that will create the schema. And then once you have this, you can use the model and call some SQL in your code to make it work. How the integration works, the magic happens in this class that I mentioned. It's a simple Java class. This is like 90% of it. We just get the operand from the model definition, and I get a Clojure function interface, and then I call that function interface using the parameters that I got from the schema factory, and then the that function that I just showed you here. Oh, sorry. Here, this will receive those parameters and create a schema for that. So that it's pretty straightforward integration, just calls into Clojure code directly, passing the parameters. And some future directions, improve calcite-clj so users can write idiomatic Clojure, write Clojure the way Clojure it's meant to be written as a list, and not use Java interop. I did some work on the OFBiz entity engine. I'm going to hopefully have some time to talk about this later in the demo part and see how far I can go with the implementation. And experiment with adding the atomic data log on top of Calcite. Data log, it's another, it's related, it's another query language, very much related to SQL, but it's more composable. It has automatic joins, so probably the talk that Alexei gave is pretty important. The work that he mentioned is pretty important to having this because Datalog has implicit joins. And the nice thing about Datalog is that it has also a machine interface, not only a human interface like SQL. So it's easy to compose in applications. So now let's go to the code, and I'll post this presentation on the website and share the link with you guys. And this is some contact information if you want to, or project links. So code-wise, I don't know, can you see the editor?
Yeah.
Yeah, okay. So code-wise, I'm using Visual Studio Code with Calva. It's a Clojure extension. Like I mentioned, this is the contents of the library. It's a single Java class with all this implementation. Same for the model here. The project is available online on GitHub, and the example is available here. So you can check it out. I'm going to show you this example right now. So all the code besides the model JSON is in a single Clojure file, about 150 lines of code. So what the code does is namespace definition, requiring some Clojure packages, importing some Java classes here. And then depths and emps, these are the data files I copied from the calcite CSV example. And it's a Clojure map that defines name, row definition, and the data for the table. The same for employees. This is the data that we're going to use, and the row definition and the employees. Then there are some utility functions to create Java types and the row types and so on. And this is the scannable table implementation in Clojure. I'm using some type hints here. They are not necessary, but they do help. Clojure can do some type checking if you provide the code with type hints. And the scannable table will receive the data above, and it will build a table implementation. It uses, like I mentioned, Proxy Plus, which is a Clojure library to implement abstract classes in Clojure. abstract classes in Clojure, they don't have native support. They're pretty hard to implement, but there is a library that you can use to have a much better experience with that. So Proxy Plus is that library that I'm using, and I'm implementing basically the stuff here. I won't go further into this right now. This is a function that creates the tables, so it returns a map, which with that I'm using the schema, and this is the function that actually creates a schema, and it's referenced into the model JSON. So you see calcite-clj simple, my schema. This is the namespace, and this is the function name, and this is the function name, and here is the namespace. Yeah, so it's pretty straightforward. So this my schema builds the schema, and then yeah, you know the rest. And I'm going to run this example right now. Clojure has a thing called, I need to switch to another. Okay, so Clojure has a thing called the REPL, which is pretty powerful. It allows you to start the application and interact with it, execute code, change it, run it again. So I can start my REPL right now in the example code. Oh, this is another, sorry. This is the, I'm going to start the REPL here. Oh, I think I need to close this one. Yeah, okay. So I'm going to start the REPL in the example. And it should start pretty soon. Hopefully I won't have any issues. So the REPL started, and right now I'm going to load this code into the REPL. I'm using hotkeys. There is a no need to concern yourself with this, but because I have a REPL, I can write some code here, and I can run it. And I did a typo. So I can run it here in the code in the REPL, because the application right now it's running, and I can change it. So right now I will execute this piece of code. So the commands, I know the commands by keyboard, but I will try to show you how to run them here. I think. Oh. Yeah, I don't find them right now, so I'll just run them by keyboard. Okay, so okay, yeah. So I just run them right now, and as you can see, I got the results back. And because we're using Clojure, I can change the data, and I can reload it and run it again if I want to. So I'm going to try to see if I can change the query. I don't have a lot of ideas right now. So age larger than 40, I will try to see if I can increase the age for someone to make it larger than 40. So we should have 2 here. Oh, there are 3 because one of them is also the null stuff. So I will increase the age of Eric to 51. And I'm going to reload evaluate the file again and reload it. And then I can execute this code again, and I should have Eric here as well. So yeah, Eric here as well. Eric, I think was also, yeah, it was also in the first one because it has a null something, I don't know. But yeah, you can see I'm confused a bit. Sorry about this. Name department. Oh, this was the department, I think. Yeah, the age was around here. So Eric, yeah, I think the age was around here. Anyway, that's kind of it on the simple example stuff. And the other part of the work is regarding OFBiz. So OFBiz, Apache OFBiz, it's an ERP system, enterprise resource planning system, and they defined their entities as XML files, and they map those to databases. So I copied them here, so they are easy to see. Yeah, so in the entities look like XML files, like tenant, and they have the column definitions and the types of these things. So I thought about this and say, would it make sense to implement to map this information as tables using Apache Calcite, and then re-implement the entity engine that Apache OFBiz has underneath, because the entity engine is not pretty flexible in my opinion, and if I could implement this as using Calcite, I could map these entities to any data source, and I managed to have some success with this. And the initial goal was to be able to parse an XML file that contains data defined in terms of those entities. And I don't think we have a lot of time. I'm 1 minute over the time that I had. But yeah, I can probably just try to run something here. So the code works, and I am essentially parsing the XML files and scanning for entities, and then I can run these types of I can run this query, for example, here. Yeah, so I just ran the query right now, and you can see that the data here is showing. Yeah, given enough time, I can probably show you a bit more, but I think this is enough for now. It was very helpful for me to have access to the talks that Stamatis did, and I think more talks for beginners are very welcome. So that's it on my part. Thank you. If you have any questions, I'm available. I'm going to stop the screen.
Yeah, thanks a lot, Ioan. Personally, I'm not very familiar with Clojure, but with your presentation, I learned a bit of Clojure, a bit Clojure integration with Java, and also close with Calcite. So definitely it will be useful when and if I need it in the future. I will know where to look. So thanks again for putting this together. Yeah, now, are there any questions from people?
I had just one, Stamatis, if that's okay.
Go ahead.
So I saw your post on the dev mailing list, and I pulled your repo the other night. I'm not a Clojure dev either, but one thing I found was that I wasn't able to get like hover definitions or type definitions from the Java classes. So in that simple example, I tried to like control click abstract table or scannable table, and I wasn't able to get any sort of like autocomplete or docs, Java docs on them. Is that normal, or is there a trick to setting up the repo so that those definitions show up?
So that question is for me, and you're referring to the example code that I put?
Yeah, so like say if you were to control click scannable table or abstract table in that repo, I wasn't able to get the type definitions for Calcite's Java classes or docs.
Okay. Clojure tooling is evolving. It's got much improved over the past year or so. Depends on what tooling you're using. I'm using Visual Studio Code with Calva extension, which is a very good extension. You might also use IntelliJ with cursive for that, and I think that has better integration with Java. But it's a bit difficult on that part, but things are improving with the Clojure LSP project, and which is integrated in Calva. I don't know if I can. For the Java classes, I cannot find stuff, but for the things that are in Clojure, I can navigate to them. So it's easy on this part, but the other ones are not.
That makes
that's
sense.
straightforward. So yeah, you're pretty much on your own with regard to this one, but things are improving quite a lot. So yeah.
Okay. Yeah, I do think that Clojure is really attractive if you're doing just like a lot of data transformations or like AST to AST transformations, because everything is just maps. So you have like EDN maps and you can just like walk them or map over them. So I was checking it out, but I couldn't get the autocomplete and the type definition for the Java classes to work. I just wanted to make sure that I wasn't doing something stupid because I don't know anything about Clojure, but that makes sense. Thank you.
Yeah, okay, thanks. You're welcome.
So I see there is another question from Maria. Do you see the question in the chat?
Yes, if XDDB, which is Clojure, has some Apache Calcite integration, not sure if you checked how they use it. XDDB is a database. It was called Crux a while ago. They renamed it, I think, in the past year or so. And I think one of the core developers from XDDB shared with me that they use Calcite in there, but I didn't check it a lot because I talked a bit, and it's not something that you can use outside of XDDB. So it's meant to be used in XDDB. The calcite-clj is meant as a library to help people integrate, write Clojure adapters for Apache Calcite and maybe some other work.
Okay, so we have time for one more question, I guess, before passing to something else. Is there somebody else who wants to ask something, Ioan? Yeah, personally, I want to mention like, in general, I found very many stuff interesting, and also the thing that you talked about introducing or, if I got it right, translating data log to Calcite.
Yeah. So data log in Clojure land, Rich Hickey, which is the creator of Clojure, with his company, they also build a database called Datomic. It has some pretty interesting features. And he chose, instead of SQL, he chose Datalog as a language for querying that database. And he built an implementation that you can you can build the queries using Clojure literals. So vectors, maps, and string literals and so like. So you can build the queries using that part. And the idea is that data log is, according to some other people as well, is much more composable than SQL because SQL was designed for humans first, but then we are in the business of building queries for APIs based on requests from users. So we kind of end up building those queries, and the solutions we have most of the times is concatenating strings or stuff like that, which is not pretty because SQL in essence wasn't built to be composed by machines APIs. And yeah, that's kind of the gist of it, I think. So yeah.
Yeah.
So it would be nice because Datalog is very similar in power to SQL. It also has some features like recursive queries and implicit joins. I don't know if I can find the link. I'll try to find a link to show some Datalog queries.
Yeah, among other things, I find that one very interesting contribution to Calcite, if it ever happens, it will be a data log to rel node converter. Like we have SQL to rel converter, and we would really appreciate other kind of similar converters. And I think like data log and other similar languages are also very useful for the academia who work much with data log, consecutive queries, and stuff like that. So something like that will be very, very nice contribution to Calcite.